All right, this is notes 3.3, solving systems of inequality. I am aware that I am in the same outfit you've probably seen me in 3 other videos in. I did all these videos on the same day, so don't judge me too hard, okay? Thanks. Okay, so in this lesson, if you guys have like 3 different colored pencils, 3 different colored highlighters, just 3 different colors, it would actually be really useful for today's lesson. So go ahead, pause the video, get those out now, and then so you can follow along. All right, so in this lesson, we will look at 2 or more linear inequalities for which a common solution is sought, called a system of inequalities. For example, consider the system whose solution is at the right. Okay, so we have a line. I know it's a line because 2x plus y is less than or equal to 8. That is standard form for a line. 2x minus y is greater than 1. Again, standard form for a line. So I have 2 lines. They intersect each other. And then the thing is we're looking for a shaded region. That whole shaded region is the solution. So any point in the shaded region will work. Okay, so let's just point out some things that we see here. What I like to do is we're just going to go ahead and change these into slope-intercept form. So I'm going to get y. Oh, why is that like that? Let's try this again. Okay, I'm going to get y is less than or equal to negative 2x plus 8. So all I did was subtract a 2x from each side. For the other one, we're going to get, and we have to be a little bit careful here, we're going to get negative y is greater than negative 2x plus 1, but we want this to be a positive y. We're going to ultimately multiply by a negative or divide by a negative. Make sure when we do this, though, that our inequality flips. So remember, whenever we multiply or divide by a negative, inequality switch. So this is actually going to be y is less than positive 2x minus 1. All right, so next I identify, and that line is blue. Okay, so this top line is the blue line here. I know that because there's a negative slope and this line's going in a negative direction. So the next thing I identify is what type of line am I going to have? Okay, so this line, since it's less than or equal to, that's going to give me a solid line. Okay, so our options are it's either solid or dashed. If there's or equals to, it's solid. If it's just like less than or greater than, then it is dashed. And then we want to know, do we shade above or below this line? So less than, it's just what you think. Less than would be below the line. Greater than would be above the line. Sometimes it gets like a little confusing, like when our lines start becoming very straight up and down. So I always imagine like taking this line and kind of like flattening it out. If I was to go more horizontal, well, what would be on top? What would be on bottom? So that's how I use my imagination. So this one is a less than. So this is solid and it's shaded below. Okay, so here it is. Here's the line. And then this would all be below. So again, if you imagine that line, or I think I'm backwards for you guys, and you were to go like this, what would be above, what would be below? And I think I did that backwards because I'm reversed on this screen. Okay, now looking at the second one, that's going to be the red line. So this one is going to be dashed because there's no equal to. So this is a dashed line. And then this one is also less than, so that one's also below. Okay, so where both of the shaded regions intersect, that is your shaded solution area. So that's why we're going to be using 3 different highlighters today. All right, so we're going to solve a system by graphing. Step 1, solve the inequality for slope-intercept form. 2, graph the inequality on the coordinate plane, shading in the appropriate half plane. Step 3, the solution to this system of inequalities is a region of overlapping areas. All right, perfect. So we're going to go through this. Okay, so step 1, I'm going to rewrite my system. I'm actually going to go ahead and just like split these into 2. So this is my first one. I have x plus 2y is less than 8. Again, we want to make this in slope intercept. So I'm going to subtract an x from both sides. So I get 2y is less than negative x plus 8. And then we have to go ahead, divide it 2. So we get y is less than, this is going to give me negative 1/2 x plus 4. Okay, right now let's go ahead and state what kind of line I'm going to have. So is this going to be a solid line or a dashed line? This one is dashed because there's no or equals to. So dashed means it's not included. It's just like when we were doing like open circle, closed circle, exact same idea. So dashed is like an open circle, solid line is like a closed circle. So this is dashed, and since it is less than, it's going to be shaded below. So let's go ahead and go graph that right now. So we have our intercept at positive 4, and then my slope is going down 1 over 2, down 1 over 2. So go ahead, get that in there. All right, let's go ahead, connect this. Let's pick the right color, perfect. Okay, so this will look like, so right there. Yeah, that was a little off. Right there. Okay, perfect. Oops. Alrighty. I'll just draw on my arrow on the other end from now on. There we go. Okay, so there's that line. Okay, so for this line, we're shading everything below it. So with a highlighter or with whatever you guys have, we're going to go ahead and shade everything below. So all of this would be shaded. All right. Okay, now let's go ahead and do our next one. So we have 3x. I don't want to use red. So we have 3x plus 2y is greater than or equal to 4. We're going to go ahead and subtract 3x from each side. So now we get 2y is greater than or equal to negative 3x plus 4. And then we have to go divide everything by 2. So we get y is greater than or equal to negative 3/2 x plus 2. All right, let's go ahead and talk about this one. So this one's going to be a solid line because it's or equal to. Oh, and look, I made a mistake. I'll go fix it in a second. So this is going to be a solid line, and this is going to go ahead and be shaded above because it's greater than. So my mistake, obviously you guys couldn't tell me my mistake because I'm talking to myself, but my mistake on my first one, it should have been a dashed line, and I did not make a dashed line. So I need to go ahead and fix that real quick. And hopefully you guys didn't make my same mistake. Let's erase this. Oh, am I not going to be able to erase that? Delete. There we go. Okay, so let me go ahead and redo that. So again, this is at 4. All right, put back in my line. I need a dashed line. And of course, that's not the color I want. Red. Dashed. Red. Okay. So it should look like that. Okay, so there's my dashed line, and it's shaded below. Let me go do my blue one now. So my blue one is solid. So a solid blue. Okay, so that one's going to go guess I need to make some dots. Okay, so that one's going to go through 2. And that one's going down 3 over 2. So down 3 over 2, down 3 over, that was only over 1, over 2, down 3 over 2, across there, and here. Perfect. All right, so now let's go draw on that line. Okay, so that's going to be like so. And this one needs to be shaded above. So let's go ahead, go shade above. So above it would be this side. Okay, and then the answer to this is wherever my 2 highlighted areas crossed each other. So they crossed each other in this region right here. And don't be as sloppy as mine. Hopefully you guys can still tell that's a dashed line. Anything on that line is not included in the solutions. And this guy is my solutions. So I'll put a nice S in there to represent our solutions. All right, next one. So same process as that one. Hopefully I can be a little more fluent on my little tablet thingy. Okay, so we have x plus 2y is less than or equal to 4. Subtract the x from each side. So we're going to get 2y is less than or equal to negative x plus 4. And then we need to go ahead and divide everything by 2. So we get y is less than or equal to negative 1/2 x plus 2. All right, let's talk about this one. Less than or equal to is going to give me a solid. Less than is going to give me a shaded below. So we're going to have a solid shaded below. So let's go ahead and graph that. Intercept is at 2. This is going down 1 over 2. Down 1 over 2. And here. All right, let's go ahead and draw ourselves a line. Oh, not that color. Okay, so it's a solid line from here to here. All right, and then this one's going to be shaded below, so get your highlighters. And we're going to shade this all below. Like so. All right, let's go ahead and do our next one. So next one is y is greater than or equal to negative x minus 1. This is already in slope-intercept form, so we don't have to do any math. Let's just talk about it. So this guy is greater than or equal to, so it's also solid. And this one's greater than, so it's shaded above. All right, intercept is at negative 1. Slope is negative 1. So down 1 over 1, down 1 over 1. Like so. I got my spots where they're going to cross. Okay. Let's go ahead and connect this with our solid line. Again, not what I wanted. There we are. So we're going to go from here to here. Okay, and then this one is going to be shaded above. So let's go ahead and shade this one above. So above would be this. Okay, again, so we're looking for my two highlighted areas. Where did they where did they cross each other? So we can see that they crossed each other. Let's get the bigger one. Right in here. Hopefully you guys are better at highlighting than I am. Okay? And then that area is my solutions. Alrighty, let's move on. Alright, go ahead, pause the video, give this one a shot by yourself. You guys should be in a position where this is getting fairly simple, just graphing your lines, shading, and then seeing where they cross over. Alright, so this one we're going to get y minus 2x is less than or equal to negative 3. So I'm going to get y is less than or equal to 2x minus 3. This guy right here is going to be solid because it's or equals to, and this will shade below because it is less than. Second one, already in a slope-intercept, so this one is also going to be solid. And this one's going to be shaded above because it's greater than. Alright, let's go ahead, plot these. So this intercepts at negative 3 with a positive 2 slope. Okay, our other one is going to be at negative 2 as our intercept, and this is a positive 1 slope. So we'll go here. Alright, let's go ahead and draw those in. Okay, so here's my red one. Okay, and that red one we need to shade below it, so this side is below. So let's go ahead and do that. So this is all below. Okay, let's go ahead and do that blue one. Also solid. Okay, that one is shaded above. Oh, oops, let's undo that. Shaded above. So this is above. So again, if you guys get confused, just imagine taking that line and just straightening it out and what would be on top of it and what would be on bottom of it. Okay, so there's a very small region where it overlaps. So it overlaps in here. So this little region would be my solutions. This is our solutions. So any point in that area would work in this system. All right, we're actually going to go ahead and skip this next one. It's using a calculator. We're not going to get into it. So let's move on to the next page. So for this next page, we're taking it up a step. So now we're talking about a linear equation with an absolute value. You guys already know how to graph absolute values. You already know how to graph lines. It's the same process. We're just looking for those overlapped areas. So let's go ahead and give this one a shot. Okay, so y is less than or equal to 4. This is just, so imagine if this was just y equals 4. We know that y equals 4 is just a horizontal line at 4. So this is just a horizontal line at 4. We just need to say, is it a solid line or a dashed line? So this one is solid because it's or equal to. And this one, since it's less than, would be shaded below. So at 4, we're going to go ahead and draw ourselves a horizontal line. At 4. And it is solid. All right. We're going to go ahead and shade this below. So all of this would be shaded. All right, next one. Hopefully we're getting better with our graphing. So this is x plus 2. It's inside. So the only thing that's happening to this parent function is that it's going to shift left, opposite of what we think. Inside's opposite of what we think. Inside's horizontal, so left, right. It's going left 2. That's my new vertex. Okay, so it's going left 2. And then this is also going to be solid because it's or equal to, and this one's going to be above, shaded above. All right, so my vertex has moved left 2, nothing else, there's no stretch or shrink, so it's just right 1, up 1, right 1, up 1. Just follow that pattern, other direction as well. Remember, absolute value graph is a V. Okay, let's go ahead and connect this with a solid. So it would be like this and like this. Okay, so that would be my absolute value graph. We want to go ahead and shade this above. Okay, so thinking about this, what's above, what's below? So it's like this. Everything up here would be above, everything down here would be below. So we're going to shade inside the V. So inside the V would be this. Okay, and then where did my two shaded regions overlap? Right inside this triangle is where it overlaps. So this is my solutions. Solutions. All right. This next one's going to be a challenge. I want you guys to give it a shot on your own. Let's just go ahead and walk through the absolute value function real quick. That negative is going to reflect it, so it's now an upside down V. The -1 is going to go right 1, plus 4, up 4. And then again, you have y is greater than -3. That's just going to be another horizontal line. So go ahead and pause the video, give that one an attempt. All right, so y is greater than -3. This is going to be a dashed line because there's no or equals to. And this is going to be shaded above because it's greater than. Okay, this next one would be a solid line. Oh, let me do it in a different color. So the next one is going to be solid. And that one's going to be shaded below because it's less than. All right, let's go ahead and graph. So this is going to be a dashed horizontal line at -3. So dashed, -3. That's like, oh, there we go. Okay, and then this one needs to be shaded above. So this is all above. All right, next one. So again, we should be pretty decent at transformations, or I'm hoping we're working towards that at least. So for this guy, it went right 1, up 4. So this would be my new vertex. It's reflected, so it's going down, and then there's no stretch or shrink, so it's just going down 1 over 1, down 1 over 1, down 1 over 1. Like so. All right, that one's going to be connected with a solid line. Okay, and then we're shading everything below it. So all of this down here is below. So let's go ahead and shade that. So below is all of this. Okay, again, we're looking for where they crossed each other. It is in that big triangle. Okay, so this would be my solutions. All right, so there's my solutions. All right, moving on. Okay, we'll go ahead and do this word problem. So it says a college entrance exam has 2 sections, a verbal section and a mathematics section. You can score a maximum of 1,600 points. For admission, the school of your choice requires a math score of at least 650. Write a system of inequalities to model the scores that meet the school's requirements. Then solve the system by graphing. All right, so let's go ahead and write our 2 equations that we can make here. So this is going to be a system. So the first one it says is it says there's 2 sections, a verbal section, so we'll call that V, and a math section, we'll call that M. And you can score a maximum of 1,600 points. So my verbal score plus my math score can score a maximum of 1,600. But it could be less than 1,600, it just can't be more than. So that's going to be a less than or equal to, because I could get a 1,600. The other one it says is for the school you're trying to go to, you need at least a 650 on your math. So math has to be greater than or equal to 650. At least 650, so it could be 650 or more. All right, so now we're going to go ahead and we're going to just graph these 2 and find our score range that we could score in and still get into this college. All right, so same as before. Step 1, we want to turn this into a, a slope-intercept form. We're going to say that the y values is m, so we're going to solve for m. So to solve for m on the first one, we're going to get m is actually less than or equal to negative v plus 1,600. Okay, second one, it's already solved for m, so m is greater than or equal to 650. All right, let's go ahead and state what kind of lines these would be. Greater than or equal to is a solid. And then it has to be less than or equal to, so this one would be shaded below. Next one, this is a solid because it's or equal to, and this one needs to be greater than, so that's going to be shaded above. All right, let's just go right over here and we're going to draw ourselves a little graph. Let me draw a little graph. So we'll just go like this. And like this. All right. Our y value, we should label our axes. Our y value is our math side, and our x values would be our verbal score. Well, that's a little crooked. All right, so let's go ahead and graph these. So this one right here is a solid below the line. We obviously know it's going to start at 0, 0, because, or not at 0, 0. Just kidding, I lied. So this one is going to start at 1600 because that's the highest score we could get, and then it's just going to go down from there. So it's going to be a negative line with a slope of 1. So we're just going to go ahead and draw that in. So the highest I could get is 1600, and then it's just going to go down like this. This is obviously not going to be exact because I'm just going to label it, and that's how it's going to be exact. So like this right here is 1600. That's my y-intercept. Okay, that one needs to be shaded below, so let's go ahead and highlight that one below. So below would be all of this. All right, my next one would be a horizontal line at 650. So let's go ahead and draw ourselves a horizontal line at 650. Again, you can pick where 650 is. So I'm going to say like right here is 650. Okay, and that would look like that. Again, let's just label it ourselves. So this is 650. All right, this one needs to be shaded above. Sorry, I was going in there. So that's above. And where do they cross each other? They cross each other in the triangle. Okay, so any score in here would be, you'd be able to get into college. So I'll tell you guys, this would be using a calculator. So I'll just go ahead and tell you guys what this point is, since we're not doing a calculator. So this crossing point right here is point 950, 650. Okay, so if you only got a 650 on your math section, you would have to get a 950 to get in. Okay, but then anything else in this range would get you into, so any of these points in here would get you into college. All right. Okay, we're actually going to skip the last one. I'm going to show you another one that we didn't cover in the notes, but I want you guys to be exposed to it. So if you guys have room, we're actually on that 4th page. Let's go ahead and go write this one in. So 1 second. Okay. So the two I want to talk about is this number 10 and this number 12. So we're going to go ahead and do those because I think they're important for you guys to see. All right, so the first one's a little bit different. And the reason it's a little bit different is x is in an absolute value sign. The thing is, this is not an absolute value function. The reason it's not an absolute value function is because there's no y, right? So for it to be an absolute value function, we would need like absolute value of x is less than y, but there's no y. So what that actually is, this is the same idea as x equals 3. But then the other value that x could be could also be -3. Okay, so hopefully that makes sense. So this, when we see this, this is actually two vertical lines, and they're going to be at x equals 3 and x equals -3. Okay, so this is two vertical lines at x equals 3 and x equals -3. Okay, we do still need to talk about, is it dashed or solid? And these would be dashed. Okay, so I hope that makes sense for you guys. I'll graph it and then I'll explain why this is the case. So let's go ahead, get a dashed line. So at -3 we have a vertical line. And at positive 3, we have a vertical line. They're both dashed. Okay, and then we would have to talk about where these are shaded from. Where these would be shaded from. Hopefully, like we did these when, I don't remember what lesson that was. When we were like graphing absolute values on the number line. Remember we like split it into two equations and graphed it. They're either going towards each other and away from each other. This is kind of the exact same idea. So this is less than, so these 2 points, so the shaded region would be going towards each other. Let's check and make sure it makes sense. So if I had -2, absolute value of -2 is less than 3. Yes, that's true. So in this region, or 0 or 1, whatever the case is, in between this region would be true. They go towards each other. Okay, so when we highlight this guy, we're going to highlight between. Okay, my second equation here is just a standard, a line. Okay, so my second one here is a line. Let's go ahead and change that line to slope-intercept form. So I'm going to get 2y is less than or equal to -4x plus 2. I'm going to get y is less than or equal to, dang it, I wish I was doing this in a different color, but whatever, -2x plus 1. Let's go ahead and graph that guy. That one is going to be solid. I know it's solid because it's less than or equal to, and it's going to be shaded below. So we have 1, and then this is going down 2 over 1, down 2 over 1, down 2 over 1. Oops, I skipped one. That is in the wrong spot. Ignore that one. All right, let's go ahead and connect this guy with a solid. So this would look like that. Okay, and then that one is going to be shaded below it. So now we're going to shade below. So this is all below. All right, and now we're looking for the region where the two shaded areas cross each other. They cross each other here. In this like trapezoid shape. Right there. And this region right here would be my solutions. All right. Again, 12 is similar. So I want us to be aware of 12 as well. So this is the absolute value of y is greater than or equal to 4. So again, absolute value equations like the v ones, they have to have an x and a y. This does not have an x or a y. So this is very similar. This is like saying the absolute value of y equals 4. Well, what are the two values that y could be where it equals 4? That would be 4 and -4. So this is two horizontal lines at 4 and -4. So, two horizontal lines at y equals 4 and y equals -4. Okay, this one would be a solid line. And again, I can't really say above or below, or I mean, no, you can't say above or below. So it's either, is it going to be shaded between or away from each other? And since this one is greater than, like we did when we were graphing, since it's greater than, it should be going away from each other. So I'm going to have two horizontal lines like this, so it needs to be shaded up here and down here. Okay, so hopefully that makes sense. So let's go ahead and do that. So at 4, oh, just kidding, this should be a solid line. Solid line. At 4. -4. Okay, if you're unsure if it should be shaded on top and bottom or in between, just test a point, okay? So like 6, if I plugged in 6, the absolute value of 6 is greater than or equal to 4. Well, yeah, that's true, so that means up here is shaded. Down here, -6, if I did -6, is the absolute value of -6 is greater than 4. Yes, that's true, so this down here is shaded. So just in case you didn't understand that, you just pick points and test it. So this up here is shaded, and this down here is shaded. All right, the next one is just a line. Our line is already in slope-intercept form, so our intercept is at 1. This has a nice steep slope of 3. Like that. Okay, this one, though, is going to be dashed, and it's dashed because there's no or equals to sign. And then this one is greater than, so it needs to be shaded above. Wow, I can't spell above. Let's try that again. Above. Just so you guys know, like, I'm a terrible speller. I hate English. I do math. Don't correct my spelling. I spell very awful. All right, so let's go ahead, connect this with a dashed and a blue. So dashed in blue, that would be like right here. Let's start, okay, like so. So again, it kind of gets confusing, like what is above on this line? Like this is a very, very steep line. So what is above? So again, I'm backwards to you guys. It's weird. So it looks like this. Okay, so again, you just take that like angle and you just start leaning it out and imagine which part of the line is being pushed on top. And that's your above, and then that's your below. So again, this is our line. Which part of the graph is being pushed above? It would be this part over here. That's the above. So let's go ahead and shade that above. So this would be my above. Okay, and then wherever these two crossed each other, that's my solutions. We actually have two different regions where we have solutions. So I have solutions up here. And then I also have solutions down here. So those are both regions. Any points in this area and that area would both work for this system. So again, so this would be a solution and that would be a solution. All right, and then I covered pretty much everything you guys are going to see. So I hope you guys have a great rest of your day, and let me know if you guys have any questions.